Inside this, simply add React Native Serial code, which is now just installed and already successfully installed. Then I will, first, specify the necessary variables here. The ref variable. React is a popular JavaScript library used for building user interfaces, particularly for single-page applications where you want a seamless user experience. It's a bit much to dive too deeply into React in this brief overview, but there are two important hooks that are commonly used, useState and useRef. To explain simply, useState is a hook that allows you to add state to your functional components. It checks and updates the state every time it changes in React, ensuring that your UI stays in sync with your data. For instance, if you have a counter component, you can use useState to keep track of the count value and update it whenever a user clicks a button to increment the count. On the other hand, useRef is another hook that allows you to persist values across renders without causing a re-render when the value changes. This is particularly useful for accessing DOM elements directly or for keeping a mutable object that does not cause re-renders when updated. For example, in my case, I use useRef to check whether the USB service has started, whether the USB is currently connected, and to add functionality related to events. This means that I can keep track of the USB connection status without triggering unnecessary re-renders of my component, which can improve performance. I've set up these three functionalities to ensure that my application can handle USB events efficiently and effectively. By using these hooks, React developers can manage state and references in a way that is both efficient and easy to understand, making it a powerful tool for building dynamic and responsive user interfaces. Then, it plays the role of the actual operation card for the serial manager. In this particular section of our discussion, we are focusing on the moment when we make a return to our previous topic. At this point, we have configured the subscription to be aligned with the pullback time subject. This setup ensures that the subscription is specifically set to respond to the pullback time subject, which is crucial for maintaining the intended functionality and ensuring that everything operates smoothly and as expected. By doing so, we are able to keep track of the necessary updates and changes that occur during the pullback time. Right, if you do it like this with front subscribe pullback, the manager that was missing here will be included. This approach ensures that the previously missing manager is now included in the process. By doing so, you make sure that the manager is actively involved. The reason for using useMemory is that the value of this variable changes based on the value being referenced here. Later on, if a command is added in the manager, the function that executes that command may change depending on the state value, which is why I have made sure to use memory. Next, we continuously listen for USB-related events in the serial context. Just register the listener and then use the device event emitter in React Native. This part is about carefully unregistering the listeners. If you are about to exit, it will change to unregister all of the necessary listeners, and here it shows how to register the listeners. I will register It's a bit much on the service, so let's leave it empty for now. The service aspect is quite overwhelming, so for the time being, we should consider leaving it unaddressed. I should originally input it, but 1, 2, 3, 4, 5, 6, 7, 8, here it is. Like this. Initially, I was supposed to input it, but let me count. 1, 2, 3, 4, 5, 6, 7, 8, and here it is presented in this manner. Data is coming in. I can listen to this, but I need to carefully organize the details for each of these tasks. First, I will thoroughly organize the functions related to when the service starts, specifically when the USB is attached or detached. This involves clarifying the details of each task and explaining the process of organizing these functions. When we say that the device is attached, it indicates that the connection has been successfully established. In this scenario, the first step is to set the attitude, which involves configuring the initial parameters or settings that the device will operate under. This is crucial for ensuring that the device functions correctly and efficiently from the start. Following this, we have a handler function that is specifically designed to initiate the service. This function acts as a bridge, facilitating the transition from a passive state to an active one, where the device can perform its intended tasks. In the event that the device is attached, there are several variables that come into play. These variables are essential for receiving and processing data, allowing the device to interact seamlessly with other components or systems. By managing these variables effectively, we ensure that the device can handle incoming information and respond appropriately, maintaining smooth operation throughout its use. Since we are using it, we can do res here and then const, which means the service has officially started and is now operational. The RF variable we created earlier is specifically for trolling purposes, and since it is now a Boolean, if the device attached is true, the handle 1 for the device attached should be executed without any delay. Let's tidy this up by organizing our code and place the recently started service here, ensuring everything is in its proper place, and then proceed with the service. This will help maintain clarity and efficiency in our workflow. Additionally, it's important to note that the service initiation process is crucial for the subsequent operations, as it sets the foundation for all future tasks. By doing so, we ensure that the system remains stable and functions as expected, providing a seamless experience for the end user. Let's make sure to double-check all connections and configurations to avoid any potential issues that might arise during the execution phase. When the service.hidden.count property is set, it indicates that the service is in the process of stopping. This is an important signal within the system's operation, as it helps manage the transition of the service from an active state to an inactive one. To ensure that the service does not continue to attempt operations while it is supposed to be stopping, it is crucial to set this property to false. By doing so, you effectively communicate to the system that the service should cease its current activities and prepare for shutdown, thereby preventing any unintended actions or errors during this transition phase.
To keep everything organized, please place the item in this designated spot. It's crucial for maintaining order and ensuring easy access. Your cooperation in placing it correctly is appreciated. Next is the error. The error is that there is an issue with the launch. Let's begin by examining how we can effectively display error messages. That may occur during our process. It's important to ensure these errors are not only visible, but also clear to the user, providing them with enough information to take corrective action if needed. In this context, we will set up two specific types of errors. The first error will be related to connectivity issues, which are common in networked environments. The second error will address data integrity problems, ensuring that any discrepancies in data are promptly identified and reported. After setting up the errors, our next step is to place the connected state within our system. This state is crucial for maintaining a stable and reliable connection, allowing for seamless data transmission and reception. Conversely, the disconnected state will be configured to effectively reverse the conditions of the connected state. This ensures that the system can handle disconnections gracefully without causing disruptions or data loss. Once we have organized the attached state, which refers to the system being actively engaged and operational, we will transition it to a detached state. This transition is important for scenarios where the system needs to be temporarily paused or disengaged without losing its current state or data. Finally, the last component we have utilized is the onReadData function. This function plays a critical role in our system by continuously monitoring and processing incoming data streams. It ensures that data is read accurately and efficiently, allowing for real-time analysis and response. Understanding these components is vital for the overall functionality of our system. In this particular scenario, our initial step involves addressing the current issue at hand. We will meticulously manage this process by first tackling the immediate concerns that arise. Subsequently, we will proceed to configure the system in such a way that it is capable of receiving and processing data inputs as an array of numerical values. This approach ensures that the data is organized efficiently, allowing for seamless integration and analysis. By setting it up in this manner, we can facilitate a smoother transition and enhance the overall functionality of the system, ultimately leading to more accurate and reliable outcomes. Has it been imported? The current situation indicates that the import process appears to have been completed successfully. However, there is an issue that has arisen, as the event that is supposed to be triggered upon reading the data is not appearing as expected. This raises a question about the underlying cause of this problem. One possibility that comes to mind is the presence of a syntax error within the code. Syntax errors can often lead to unexpected behavior in software applications, as they prevent the code from executing correctly. It is crucial to thoroughly review the code to identify any potential syntax issues that might be causing this malfunction. Additionally, it is important to consider other factors that could be contributing to this problem, such as configuration settings or compatibility issues with the data format. By systematically investigating these areas, we can work towards resolving the issue and ensuring that the event-driven functionality operates as intended. So when this event is triggered here, it gets sent to all the ones that are subscribed in this manager command. I carefully placed it down here as well, making sure everything was in order. Then, I proceeded to handle the task of reading the data thoroughly and efficiently. Handle on the collected and processed read data. Alright, for now what's missing is...
At first, this context is inserted here, and then the listener mode is registered. And if there are any changes,
During this monitoring, we remove all listeners and then add the listeners again. But some people might wonder why we remove all listeners instead of just changing the modified ones. Originally, it should have been possible to remove specific functions as listeners, but it didn't work out that way due to certain technical limitations and unforeseen complications in the implementation process. That's why we opted for removing all listeners, as it ensures a clean slate and avoids potential conflicts or errors that might arise from partial modifications. Now, the last thing I need to do is that, in my case, I have set it to automatic connection. This setting is particularly useful in scenarios where manual intervention is not feasible or when the system needs to operate independently without constant supervision. It might change to manual later, depending on the requirements and feedback from users, but for now, once this is executed, it will automatically connect to the USB serial one by one, ensuring seamless and uninterrupted communication. Later, I will also explain the manual process in detail, providing step-by-step instructions and tips for troubleshooting common issues. Starting with the manual might be difficult, especially for those unfamiliar with the technical aspects, so below is the definition of the serial port settings, which outlines the necessary parameters and configurations required for successful operation. The example is set up with a hexadecimal string, which is a sequence of characters representing binary data in a readable format. However, if that's the case, it will need to be parsed again, which can be quite cumbersome and time-consuming. Therefore, I decided to set it up with an inter-array, which is more efficient for our purposes. For the connection, to set auto-connected for the rate, I've set it to the rate constant, which is a predefined value, so I called that function. Then, I executed rn-gearboot, and for the interface, I set the interface constant to -1, which is a standard practice in this context. And for now, I will proceed with auto-connect as a professional approach. Initially, I want to make the process of connecting automatically as seamless as possible for you. This is because, in the beginning, setting up a system that operates automatically can save a lot of time and effort in the long run. Even though I might later inform you about how to do it manually, having an automatic connection ensures that you don't have to worry about the technical details every time you need to connect. To achieve this, we will first set up everything necessary to ensure that the USB start and USB services are fully operational. This involves checking all the configurations and making sure that each component is correctly installed and functioning as expected. Once everything is set up, we will monitor the system to ensure that it continues to work smoothly. If at any point this component becomes disconnected, it is crucial to check for any active connections. Active connections can sometimes cause issues if not properly managed. Therefore, if we detect any active connections, we will proceed to disconnect the USB service. This step is important to prevent any potential conflicts or errors that might arise from lingering connections. After disconnecting, we will include the component again to ensure that everything is reset and functioning correctly. This precautionary step helps in maintaining the integrity of the system and ensures that there are no errors. However, there might still be a chance of encountering errors, and it's important to understand why this could happen. Errors can occur due to various reasons, such as software glitches, hardware malfunctions, or incorrect configurations. By being aware of these possibilities, we can take proactive measures to address them promptly. In summary, the goal is to establish a reliable and efficient automatic connection process while being prepared to handle any issues that may arise. Everything is organized now. I have Zhengli add the context related to serial communication. So, if you look here, why might an error occur? As you can see here, it says that the number type cannot be used here, but in reality, they tell you to set it as a number type, which is a kind of bug they created, right? Did it come over by calling that as return data types? Oh, indeed it has been called. Perhaps indeed. You just simply need to wrap it with as just once. Then there won't be any errors. Right. There are no errors. Now everything is ready. And as you can see, this is a context that can control the serial manager where we have registered listeners for USB communication-related events internally. These listeners are crucial for ensuring that the system can respond to USB events efficiently and effectively. Initially, when it operates, it sets up the USB service, which involves initializing various components and ensuring that all necessary resources are allocated and ready for use. This setup process is vital for the smooth operation of the USB service. When this component is detached, or when the context is detached, it stops the USB service, which involves releasing resources and ensuring that no processes are left running that could cause issues later. So, in actual use, instead of using text serial, you can wrap it as serial provider super M in the app. This wrapping provides a more robust and flexible solution, allowing for easier integration and management within the application. By using serial provider super M, developers can take advantage of advanced features and improve performance, making it a superior choice for handling serial communication in modern applications. This time, I implemented the remaining essential logic of the serial context. As you can see, I added a serial provider on the app side, allowing the use of the serial context. Next time, we will connect the Arduino and Android to check if the values sent from the Arduino are received correctly on the Android. Then, I will see you next time.